Now R squared is another name for R squared is coefficient of determination. Okay. Coefficient of determination is SSR divided by SST. Okay. So this is our SSR, sum of squares of regression. Okay. And SST is the total. So we need to find the total here. The total degrees of freedom is that, and the total is here. Okay. So our R squared is the sum of squares explained by the regression model, so divided by the total. So in effect, what we're saying is that this total of that much variability, total sum of squares is total variability in Y. Okay. Of that portion is explained by the model, and that's what is left remaining. Okay. So this ratio tells us the proportion of variability explained by the regression. So if the entirety of the variation is explained by the regression, then SSR will be equal to SST, the value will be 1. It cannot be greater than that. Okay. And if the model does nothing at all, it gives 0, then your numerator is going to be 0, so R squared will be 0. So the value of R squared is between 0 and 1. Okay. Closer to 1 means it explains most of the regression. Closer to 0 means it doesn't do anything at all. Okay. All right. Now we have another thing called adjusted R squared. Okay. Now the nature of the computation, the mathematical computation, is such that if you add more variables into the model, so now we have only 4 variables, okay? Put 1 more, put 1 more, put 10 more. Okay? The SSR will never go down. Okay? It will always go up. So even if the variable is not doing a whole lot, it is still putting more and more variable into the model will never affect R squared value. R squared value is that if the variable is doing nothing at all, R squared will stay the same. If it does a little bit, it will go up only. So it can only go up. So if you look at only R squared, then you keep on adding more and more variables. That's no good at all. So you need to look at when you add variables into the model, you are adding more complexity, and there is a cost to that. And R squared just ignores that cost. It just simply looks at the benefit only. It doesn't look at the cost. Right? That's where this adjusted R squared comes into picture. So it says, okay, all right, I'm going to look at the benefit, which is the reduction in R, the increase in the sum of squares of R. And I'm also going to look at the degrees of freedom that is lost, because you're going to increase this degrees of freedom, and so the degrees of freedom here is going to keep going down for the error. So that's not a good thing. So that's what R squared, adjusted R squared is. It adjusts for the fact that you're adding more variable into the model. So it is 1 minus, okay. So n minus 1 is the degrees of freedom of the total, okay, divided by n minus p minus 1 is the degrees of freedom of the model. So that ratio gives you this part. Okay. And then you multiply by 1 minus R squared, so that gives you adjusted R squared. So when you're trying to figure out whether it is worthwhile to add more variables into the model, don't look at R squared, look at adjusted R squared. See whether adjusted R squared is going up. If the adjusted R squared is not going up, or it may even go down, then that new variable is not adding any value to you. The cost of adding that new variable is more than any nominal improvement that variable may be offering you. So you won't include that variable. Okay, so that's what adjusted R squared does. Okay, I made a mistake. It can't be negative. That's P. So this is n minus P minus 1. So this should be that. Well, okay, I think it's a good idea to look at how the, yeah, so that's the right answer, okay. Let's look at how the,
Can I see that one more time, though? Or just
okay, I'm going to do this. Okay, so let's so here n is equal to number of observations. P is equal to number of independent variables. Okay. So this will be n minus 1, degrees of freedom is n minus 1. Okay. So this is P. This is n minus P minus n minus n minus P minus 1. Okay. So this is SSR, SSE, and SST. That is, sum of squares regression is SSR. Okay. SSE is sum of squares error, and SST is sum of squares total. This is MSR. MSR is SSR divided by the degrees of freedom, which is P. Okay. Then this is MSE, that is SSE divided by the degrees of freedom here, which is n minus P minus 1. So that's what that is. Okay. And we don't compute mean total square, no. We only need these two. Okay. And then the F value is MSR divided by MSE. So that's how the whole thing gets built. Okay. So n minus P minus 1 is the degrees of freedom of the residual, not of the model. Okay.